Well, good morning, everybody. My name is Hendrik Thiel. I'm the sales director of HEITEC, German company. And today I have the pleasure to talk a little bit about module standards and comparison. During the last day, we heard a lot of, well, smaller form factors. And today, well, I'd like to take a look at the different smaller form factor mezzanine cards that we actually already have, and to talk about the technical possibilities and limits of the different plug-on boards. Well, the topics I'm going to talk about is the historical review, the technical comparison of them, kind of also having a look from the market view by architecture and availability, and then coming to a summary and making a short conclusion of it. Well, the historical review. Last year I talked about the different backplane architectures. And if we are looking at the mezzanine cards, we also see that the development is progressing constantly. COM-HPC was already introduced in 2005, Qseven in 2010, and SMARC in 2013, which means, well, these are the three that I'm going to talk about today. What we see in the end is that we see COM-HPC, which is going to be introduced during this year probably, which is going to be kind of an add-on for the server type plug-on units. Looking at the technical comparison, well, we made it a little bit easier than last year. We did not put so much things into this table in order to talk about. We see that all of the different plug-on board units are supporting an x86 CPU unit, which is an Intel one for instance. But Qseven and SMARC are also supporting ARM architectures. We put three different types of COM-HPC boards into our comparison: Type 6, Type 7, and Type 10, which is nothing else than the different type of pinouts that we have on these. If we're looking at the connectivity, we see that the smaller ones, kind of Qseven and SMARC, are providing 4 lanes for PCI Express up to Gen 3. If we are looking at the COM-HPC modules, we are seeing that the Type 10 with the pinout, which is the most easiest one, also provides 4 lanes, but the other two types, Type 6 and Type 7, which are the most common ones, are providing 24 or 32 lanes. All of them are providing USB interfaces from 8 times USB 2.0 and 3 times USB 3.0 up to USB 3.1, and this is nothing which could be really comparable. But if we are looking at the pin count, which is on the boards connecting via this defined interface, we are seeing huge differences. The Type 10 pinout from COM-HPC only provides 1 time 220 pins. Qseven and SMARC are defined because of their pinouts, but I'm coming to this later on. They have 230 or 314 pins. COM-HPC Type 6 and Type 7 provide 2 times 220 pins, which gives you a lot of opportunities in order to put in more interfaces, more IOs that you can use on your own. If we're looking at the power consumption, we also see a huge difference. Qseven is up to 12 watts, SMARC up to 15 watts, and COM-HPC Type 6 and Type 7 up to 116 watts of power consumption. If we are just making it to a point from the technical features, we see that Qseven is less complex. From the design perspective, it's mostly used for edge devices, thin clients. SMARC, a little bit further in the complexity. Complex visualization solutions, IoT gateways that use these standard modules that are providing enough CPU power. COM-HPC, on the other hand, Type 6, mid-level applications in the transportation field for robotics, industrial controls, HMIs. Type 7, already microservers or server applications that use these standard plug-on boards. Type 10, which is constantly going down, low power applications like mobiles, handhelds, devices, all of your, or most of your tablets that you're using have kind of a Type 10 connection COM-HPC module in there. But having a look at the sizes of these boards, Q7, the standard Q7 is 70 via 70 millimeters. Micro Q7, it's only kind of your credit card form factor, 70 via 40 millimeters of scale. And you see that there are kind of these standard pinouts that you have on these different plug-on boards. If we're looking at the SMARC, you see it's even a bigger scale, 82 via 80 millimeters, and the small SMARC 82 via 50 millimeters. Also as well, standard connection via the pinout that you see on the top over here. There is no differentiation in between. If we are looking at the COM-Express boards, the extended board, which is not used that much, but there you see you have two connectors on the top with a pinout, which is able to provide these lot of different things. The standard COM-Express, 125 via 95 millimeters. Also again, these 2 times 210 pins. COM-Express Compact, 95 via 95 millimeters, which is one of the most common ones. And COM-Express Mini, type 10 pin out, only these few pins that I talked about already. These are the different form factors. You see that they're also in the standard plug-on board units. You have the differentiation in between bigger ones and smaller ones. Maybe this could be an answer for your questions, where we see the future is going to using smaller form factors. The qualitative comparison, if we're looking at bandwidth, signal variety, pin count, performance, ruggedness, maximum power consumption, or the mod size, well, we see that COM-Express is providing us the most variety and the most powerful solution, which is then normally used for CPUs. SMARC is kind of somewhere in the middle in between the two of them, because it's already providing certain bandwidth, signal variety, pin count, and performance. It's not providing you so much power consumption as COM-Express can. Q7, this is honestly the low-cost, mid-performance standard board you can use for your application, but it's not that variable as the other two. Just bringing it to a certain overview how you can see it. If we are looking at the high performance solution and the signal diversity, you see that Q7 is very, very limited. SMARC is somewhere in the middle, and COM-Express is providing you the top solution regarding signal diversity and the performance. If you are looking at these bullets that we have over there, this also shows a bit of the market share that these products are having. Q7 is not so familiar in the market. SMARC the same, but COM-Express is what a lot of customers use. We will also see this in the next slides when we look at the market overview. You can see that COM-Express is having more than 60% of the market shares. Q7 and SMARC and others are having 38%. This is what I also wanted to show you in the last one by putting these bigger bullets on it. The total market size of system on modules or plug-on modules across all market segments and processor architectures is guesstimated over $3.5 billion by 2025. Why is it only guesstimated? We don't have any real numbers looking forward, but we see it as a real growing market. Industries such as defense, energy, healthcare, transportation are increasingly adopting these modules. We have several projects in Europe where we are using these standard form factors in order to get a pretty fast and easy programmable solution for our customers, only providing these customer-specific developments that are needed in order to get the I/Os that these guys need. 3, well, maybe 4 in future leading system on modules with standardized interfaces will be there in the market. It's Q7, it's SMARC, it's COM-Express, and then COM-HPC. If we are looking at COM-Express, COM-Express describes 8 different types of the pinouts, type 1 to 7 and type 10. I was only talking about 3 different types. Why? because type 1, 3, 4, and 5 are obsolete and no longer relevant for new board designs. Type 10, mainly used in COM-Express Mini, it's also going down. Type 6, mainly used in COM-Express Compact, and Type 7 on COM-Express Basic. There you can also see the market share. COM-Express Basic and COM-Express Compact are not even the same level, but COM-Express Basic, the standard one, is having nearly 50% of the market shares inside the COM-Express. COM-Express Compact is growing because it's kind of throwing COM-Express Mini out of the market. COM-Express modules are only having x86 architectures. They are not supporting an ARM architecture. If we are looking at Qseven and SMARC, the performance classification is also reflected in the availability of processor architectures at SMARC and Qseven. Well, you do not get the newest generations on a SMARC or even a Qseven board. ARM processors convince through efficiency, which is predestined for mobile devices or devices with lower power performance requirements. That means I don't have to be at the rocket science of the new CPU units, Gen 5 or however, with these modules, because I don't need this CPU power on these type of plug-on boards because there is no real time needed or something like that. x86 processors, which are produced by Intel or AMD, are suitable for more complex solutions. That's what I mean by talking about big data, IoT devices. That's what COM-Express is normally used for because they always have the need of customer-specific interfaces or many, many interfaces which are necessary for even advancing digital and digitalization and visualization. That means we are seeing a lot of different applications regarding these edge computing IoT devices, collecting data and putting them into the cloud. Well, coming already to the point, summary and conclusions. If we are looking at the application complexity, well, starting with Qseven, the number of pins is very limited, the power consumption is limited up to 12 watts. I only have 4 PCI Express lanes and 1 time gigabit Ethernet. It provides USB 3.0. Yes, SMARC is having more I/O pins that I can define, 314 in this case. It can go up to 15 watts of power consumption. Also again, 4 PCI Express lanes, but 2 times 1 gigabyte Ethernet. COM-Express, different story. Up to 440 pins, up to 116 watt of power consumption, up to 32 PCI Express lanes, up to 5 times 1 gigabit Ethernet, and also already providing USB 3.1. This is where we see the future is. COM-HPC, up to 800 pins, up to 300 watts, up to 64 PCI Express lanes, up to 8 times 25 gigabit Ethernet. We also heard about this the last days, and providing USB.4. But this is not kind of replacing COM-Express. This is kind of an add-on. It's just extending the COM-Express to server on module thoughts. It's just having a look at these needs from the industry. So this is already what I want to talk about. Thank you very much. Any questions from your side?